and we will paste it in here. All right, and to test out our service, let's do a systemctl start API. And we're going to have to put in our password. And so this started our API. And if we do a systemctl status API, whoops, there shouldn't be a space, ctl status API, this should just give us the status of our service. We can see that it looks like it failed. That's not good. And it's going to provide us some logs. And if we take a look at the logs, you can see algorithm, field required, access token, expires, field required. So it looks like something is wrong with our environment variables, because we saw the same exact error when we were originally setting this up before we got the environment variable. So for some reason, it's not actually accepting these environment variables. And the reason for this is that the service file, the service that you create, doesn't have access to users' environment variables. And if you actually go back to our home directory, and then we go to ls, ls-la, remember we created this env file, and then we loaded it in the .profile. So the environment variables that get loaded from .profile aren't accessible within a service. And that's just the way services work. So what we have to do is we have to pass in another field in our service config so that it knows to pull the environment variables from that specific file. So what we can do here is in this file, we're going to go and just add another line. It doesn't matter where you add the line, but we want to say environment file. Make sure to capitalize the E and the F equals, and then you provide the path to your specific env file. So mine's going to be home/sanjeev.env. And I'll just copy all of this again. And we'll go back into etc systemd system. And then I'll just do a sudo vi api.service. And we're going to replace this file now. All right, so now we should be able to import all of those environment variables. And there's other ways to do this. You can also set up a config file for your new service. However, I figured it's just easier because we already have our environment our .env file, so we can just continue to use that. And now if I do a systemctl restart API, and notice you don't have to type in api.service. It's optional. You can technically do it like this. And it looks like since we actually changed the file, we have to run this command now. All right, and so now let's do a systemctl restart. Sorry, not restart, status API. And looks like we got the same exact error. Let's just do a restart one more time. And we'll do a status. And now it's up and running. Perfect. Look at that. So we've got our 4 workers. These are the process IDs. And let's just double check and make sure that we can access our specific website. So I'm going to just refresh on the /docs. And it looks like it works. Let's go to the root. And let's go to the root URL. So I'll just change this to the root URL and see if we get the API response. Perfect. So it looks like we've got our application up and running. There's just one last thing we need to do. And I wasn't sure if I had already covered this, but there's one last thing I want to do, and that is I want to make sure that our service automatically starts upon a reboot. So that way, in case our machine goes down, whether it's because of a power failure or something like that, or maybe we perform some sort of upgrade, I wanted to automatically start this service so that our application is always up and running. If you do a systemctl status API, you could find out pretty easily whether this service is going to get started upon a reboot. So if you take a look right here under loaded, and then right here is the keyword that you're looking for. If you see disabled right here, that means that it's not going to automatically get started upon a reboot. If you see it's enabled, that means it will automatically get started upon a reboot. So to actually make sure that it actually does get started upon a reboot, just do a sudo systemctl enable and then the name of the service, which is API. And after that, if we do a status again, we should see that it moved to enabled. And so now if we reboot our machine, and you guys can go ahead and test this, you'll see that it automatically starts up the service. Right now, the way that we have our deployment set up is that when we send a request to our server, to the specific IP address of our server and whatever port we decided to configure our app to listen on, we send that request directly to the app or gUnicorn in general. And this is technically perfectly fine. However, you'll see that in more professional type deployments, what we'll have is a intermediary web server. So we'll have a web server running on our Ubuntu machine, and that web server will receive the original request and then act as a proxy and proxy that request to our specific application or gUnicorn in this case. And so one of the common web servers that can be used for that is Nginx. There's a couple others like Traffic and HAProxy. You'll see that Nginx is fairly popular though. And some of the benefits of doing this or in configuring our application ultimately to be deployed like this is that Nginx is optimized for SSL termination. So Nginx is a high performance server and it can perform all of the SSL termination. So when we send an HTTPS request, we can send it to our Nginx server. The Nginx server can process it and then forward it as a plain HTTP packet to our application. Because technically we could configure our application to handle HTTPS, it's not optimized for that, right? Our app is designed to just act as a plain API. When we start adding responsibilities like performing SSL offload, well, then you'll see that we start to see a degradation in performance. And Nginx, like I said, is a high performance web server. It's optimized for this, so it makes sense to kind of handle that responsibility on Nginx instead of our application. So that's what we're going to do. We're going to configure Nginx, and this is going to act as the gateway into our system. So any request we send to our system, whether it's HTTPS or HTTP, doesn't really matter. We're going to send it to Nginx. And if we send it as HTTPS, what Nginx will do is it'll then take it and send it and forward it as an HTTP packet to our application. And so I'm going to walk you through how to set up Nginx. It's not difficult. We do have one config file that we have to add, but outside of that, it's fairly easy to get this up and running. Let's install Nginx now. To install a package, we can do sudo apt install and then Nginx and then -y. So that installed Nginx. If we do a systemctl start Nginx, that's going to start up the Nginx service. And so now if you go to your server IP address, you're going to see that you get this welcome message. So this is just the default page that Nginx loads up for you. And we're going to change this. So in Nginx, what we want to do is we want to go to /etc Nginx sites and then available. It's important that you do available because there's also a sites enabled, which is not what you want. You want available. And there's this default config file, or technically this is a server block. And if we take a look at this, you can see the default configuration in this case. Just to show you what that looks like, you can see that this is handling HTTP traffic. That's why it's port 80. It's going to listen on port 80. And this is going to act as the default server. So all requests that come here are going to land on this server block. And we've got the same thing for IPv6 as well. And then this is the file that you actually see. So when you navigate to this page, it's actually loading up a file that's in /var/www/html. And then the server name. So this is going to be the actual domain names it's going to handle requests for. This is basically saying everything. Everything else, don't worry too much about that. But what we're going to do is we're going to change that file a little bit. And I've provided an example file here. And so this is what the example file looks like. We can leave pretty much everything in place. The only thing I want to change is this location block. And so this is what is going to allow Nginx to act as a proxy, specifically this line. This is the main line. You don't technically need the other ones. Those are more of optimizations. But all this is saying is that any requests that match the root path or beyond, essentially, is going to get proxied to localhost port 8000, which is what gUnicorn is running on. So you just specify the IP address and the port that you want to proxy traffic for. And so since gUnicorn was configured to run on port 8000, we're just going to forward it to gUnicorn in this case. So I want you to just copy these lines here, and we're going to go in, and I'm going to just open up that default file now. And we can delete these 3 lines. I'm just going to paste that in. And at that point, I can save this. And then we want to do a systemctl restart nginx. So it's restarted. And if I refresh this, right, we can now see our API. And if I go to /docs, it should also work as well. So we got nginx set up and running. The last thing that we have to do regarding nginx specifically, well, it's not really nginx specific, but in general, is that right now, if you take a look at it, you can see our web browser says not secure. And that's because I can actually copy this. If I paste it, right, we're using HTTP and not HTTPS. So we need to set this up for HTTPS. So how do we do that? Well, we're going to tackle that in the next video. But you're going to need a domain name if you want this to work with HTTPS. So I'll show you guys how to kind of grab a cheap domain name. However, if you don't have one, don't worry. You can just leave it as HTTPS for now, or you can create a self-signed certificate, whichever one works for you. For my application, I purchased a domain name called sanjeev.xyz. So if you've ever watched any of my other videos, this is always the default domain name that I use for demonstration purposes. You can see that I actually bought a .xyz because they're the cheapest. So if you just want to play around just for learning purposes, get a .xyz. They're usually like $1 for like an entire year. But if you get a .com, it's going to be a little bit more expensive. However, depending on what your domain name is, it at most is still, well, not at most, but you can still find plenty at $12 per year. So it's not too bad. And I happened to purchase my domain name from Namescheap. So this is my domain registrar. However, there's plenty of other options. If you want to use GoDaddy, if you want to use any of the other websites, you can even use Amazon if you wanted to. Feel free to use whichever one you want. You just need to get a domain name. I'm going to be using this one moving forward. So just keep that in mind. And what we want to do is we want to set up a couple of rules. And we actually have to point our domain name to DigitalOcean. And DigitalOcean has this excellent write-up, how to point your DigitalOcean name servers from common domain registrars. And they actually show you how to do this for a lot of the main domain registrars. And they have Namescheap here as well. So if you get one of these, you can just follow along. But you'll see that any domain provider, you'll be able to kind of relatively click around and just kind of navigate yourself and figure out what's the equivalent. Because for the most part, the UIs are all fairly similar. But if we go down to Namescheap, you can see that what we have to do is under the name server section, we have to do custom DNS. And then we point it to the DNS servers of DigitalOcean. So ns1.digitalocean.com, ns2, ns3. So let's do that. And I've actually already set that up for us. So you just go under name servers, select custom DNS, and then you have ns1 digitalocean.com, ns2 digitalocean.com, and ns3 digitalocean.com. And there'll be a little check mark, so just check that there. And at that point, it's going to point everything to our DigitalOcean servers. Then in DigitalOcean, if you just select your name here in your dashboard, what you want to do is you want to go to manage DNS on DigitalOcean. And then here you want to enter your domain. So this is going to be sanjeev.xyz. We'll add this domain. And the first thing that we have to do is we have to create an A record. So this is the root of your domain. So I'm just going to say @symbol. This is going to create an A record. And we want to select the specific droplet that we created. So this one is Ubuntu Fast API. You should only have one. But if you have other droplets, make sure you select the right one. And then select create record. And at this point, if we do sanjeev.xyz in our web browser, it's going to take us to our DigitalOcean server. However, keep in mind, the changes to DNS usually take a little while to propagate. So you could potentially have to wait up to an hour or 2 hours. Namescheap says it could take up to a day, but it never takes a day. So if you don't see these changes immediately, just give it 10, 15 minutes, and then you'll see that they work. But I'm going to add one more, and that's going to be for my subdomain, because I don't want to just do sanjeev.xyz. I also want to redirect www.sanjeev.xyz to my server. So I can create a CNAME record. And I can say www. And so you can see what this is going to look like. And I'm just going to say @ symbol right here. So that's going to point it to this record essentially. All right. And so what this is saying is that if you send a request to sanjeev.xyz, it's going to send it to the IP address of our server. And then if you send a request to the subdomain of www.sanjeev.xyz, it's going to be an alias for sanjeev.xyz. So it's essentially just going to follow this. All right. And so now if I go to sanjeev.xyz, you can see that we are successfully able to access our API. And if I go to /docs, once again, this should still work as well. And that's pretty big. Let me minimize that. And if I do the same thing for my subdomain of www.sanjeev.xyz, this should also work. All right, so we've got our domain set up. And once we have our domain, we can now finally set up SSL. So we can handle secure HTTPS traffic because we don't want to send our application traffic over HTTP. And we want that nice little lock symbol, that green lock symbol. So we'll tackle that in the next video. Okay, so it's now time to set up SSL for our application. So I want you to search for certbot. So this is the website for Let's Encrypt, which is a free SSL service. And here they've got excellent documentation. What we want to do is select get certbot instructions, and then we can just specify what software we're running. So this is for Nginx, and the system is going to be Ubuntu 20.0.4. The reason it asks for this information is that it actually will automatically reconfigure Nginx for you to handle HTTPS because normally when you want to set up HTTPS, you have to change some configs in Nginx, and it gets a little complicated. And so it's saying the first thing that we have to do is we have to install snapd. If you installed Ubuntu from DigitalOcean, snapd should automatically be installed for you. So you can do snapd -- version, I think. Or is it snap -- version? I think it's snap version. Yeah. Okay. So it's snap. Okay. So we've got snap installed. That's perfect. And then what we want to do is we want to install with this command right here. So just copy this. And we're pretty much just going to follow this website because like I said, the instructions are fantastic. So we'll install certbot. All right, certbot's installed. Then we want to do this command. So you have two options. You can either just generate a certificate, or you can have certbot automatically configure Nginx for you. We're going to have certbot do the work for us. And so we can just paste this in. All right, and then we have to provide an email address. So this is going to be whatever email you want to use. And then we got to agree to the terms of service. You can do no for this one. All right, then we have to specify what domain names we want to generate a certificate for. So we want to generate a certificate for sanjeev.xyz in my case, and then www.sanjeev.xyz. All right, and it looks like it did some magic to our default config file that we were originally changing. So if we actually go to the sites available folder, which we're already at, and just do a cat default, you're going to notice some changes to this file. And that's because certbot actually made a whole bunch of changes. And the main change is, where are these changes? Not here, not here. Here we go. So this server block is for SSL configuration. And so these are the changes they made. So we're going to listen on port 443. So that's the default SSL or HTTPS port. That's good. And I guess that's for IPv6. This is for IPv4. These are going to be the two certificates that were generated. And then there's a few other configs that it added. And we also have this server block right here, which is going to actually redirect HTTP requests to HTTPS. So we can never even use HTTP anymore. It's going to ensure that our clients always use HTTPS and it'll redirect them to HTTPS. And if you can see that right here, if host equals www.sanjeev.xyz, we want to send a 301 redirect to HTTPS and then host request right here. And we're doing the same thing for just the sanjeev.xyz. And so that's all done by certbot. And so now if I go here and I do sanjeev.xyz, take a look at this. We got the little green lock. That means connection secure. That means we're using HTTPS, and you can see the HTTPS here. And if I hard code it to be HTTP, look at that. It still has the lock because it redirected to HTTPS. And let's just make sure that the docs work now. And it looks like the docs still work. So we now have HTTPS set up on our Nginx server. And just like we did with our service, we want to make sure that Nginx has been set up to automatically start upon a reboot. So we could do a systemctl status Nginx, and let's just quickly verify if it has been set up to do so. And I can see that on mine it's set up to be enabled, so it will automatically start upon reboot, which is what we want. And I think this is the default configuration when you install and set up Nginx. However, if you see disabled here, just go ahead and do a systemctl enable Nginx, and that's going to make sure that it will be moved to an enabled state so it'll get started upon a reboot. The last thing that we need to do to complete our deployment process is set up a firewall on our machine. And the reason we want to set up a firewall is just for basic security purposes. We want to make sure that we only open up ports that we're going to be using. Because right now you can access this box on any port, and we want to make sure that we really harden our system so that only the traffic that should be sent to this box is allowed to this box. We don't want people trying to connect to different services on our machine that they shouldn't be. So we're going to be using the built-in firewall called a UFW. And if we do a sudo UFW status, right, the UFW is the firewall. And so you can see right now it's inactive, and that's perfect. And what we have to do is we have to set up a whole bunch of rules. And we have to tell the firewall what kind of traffic should we allow to our machine. And we can run sudo UFW allow, and then we can specify what specific port we want to allow traffic on, what specific IP addresses we should be able to talk to. So since this is a public API, we want to make sure that technically anyone can access our server from HTTP and HTTPS. So we're going to do allow HTTP. So this is going to allow HTTP traffic. And you can see it created an IPv4 and an IPv6 rule. We want to allow HTTPS traffic. And keep in mind, we have to SSH to our machine so we can access it. So we have to allow SSH as well. And if you wanted to, you could also allow 5432. So that's going to be to allow Postgres traffic. Now, the way we've set things up, you don't need to actually allow this port because technically our app, right, our fast API is running on the local machine. So it's not going to be hindered by this firewall. So it can access the database because it's running on the local machine. So if you wanted to make it so that no one from the outside world can directly access your database, you would not want to allow this. And that's what a lot of people do because it can be a little risky opening up your database port because then people can potentially access your database. So it's up to you. However, if you want to be able to, go to pgadmin, and if you want to be able to connect to your box remotely, then you're going to have to allow 5432. So it's just up to you. It's your preference. Do whatever you want to do. I'm going to allow this just for demonstration purposes so that I can show you that, hey, when you allow 5432, we can connect remotely. So I'll add that rule. And then finally, we have to start our firewall. So we do sudo UFW enable. And it's just going to tell us that we could potentially lose connection because we're starting up a firewall. That's fine. And we've started up a firewall. So if I do a sudo UFW status, you can see that it's active and you can see all the rules that it's put in place. So it's saying we allow port 80 traffic from anywhere. We're going to allow that. Port 443, we're going to allow from anywhere. And same thing with SSH and 5432 and all of the IPv6 rules as well. And then everything else is dropped and blocked. And let's just double check that we can access the docs. And it looks like we can. And just to make sure it's not cached or something like that. Still works. And now we've got our firewall. And the firewall will start up automatically, so you don't actually have to configure anything else. If you do want to delete a rule, you can do sudo UFW delete allow, and then whatever rule. So you can do HTTP or you can do 5432. Whichever one you want to delete. So now that we have our application deployed, one of the common things that you're going to have to do is make changes to your application and then push out those changes. So I'm going to show you guys how we can do this in a manual process. Ultimately, if you're developing an application, it's best to set up a very efficient CI/CD pipeline, but that's a little outside of the scope of this course. So I'm going to just show you how to do this manually. and you'll see that it only requires a couple of commands. So go ahead and make your changes, whatever code changes. So I'm going to say, hello world, couple of exclamation points. All right, we'll save that. And what we're going to do is we're going to do a git add -- all again. And we're going to do a git commit -m, give it some meaningful message. Changed the world. All right, and then we're going to do a git push. And before we do that, if you type in, just do a git push. Then we provide origin, which is the name of our remote, and then the branch that we're on. So we can say main. And that's going to push it up to our GitHub repository. And at that point, once it's there, you can just quickly verify if you want, but I'm going to assume that it's there. And then what we're going to do is we're going to go into our application folder, which is in our home directory. Then we go into apps and then source. And then here, we're just going to do a git pull. So it's going to pull all the changes that were made. So it's going to grab the latest changes and we'll... All right, so we've pulled all of our code now. And keep in mind, if you had changed the requirements.txt file, then you definitely want to do a pip install, pip install -r requirements.txt if you did, but we didn't change any of that, so we don't need to do that. And what we can do now is we have to restart our application, because if I just refresh this, you can see nothing's changed. There's no exclamation points. So we'll do a sudo systemctl restart API. And let's try this out now. And we've got all of the exclamation points now. So that's how you push out changes through a manual process. But like I said, it's best to set up a CI/CD pipeline. In this section, we're going to focus on Dockerizing our application. I originally wasn't going to do anything on Docker, but I figured I would just make a quick video just to show you guys how we can quickly set up our fast API environment within a Docker-based environment. And I'll also show you guys how to set up a Postgres database within Docker. This is going to be a fairly quick run through of Docker. I'm going to assume that you guys have a basic understanding of Docker. I'm going to assume that you already have Docker installed on your machine. So we're going to get right to it and get started on setting up our fast API within Docker. So I have Docker Hub open, which is just, a public repository of different images that we have access to. You can create an account if you want to. You don't have to create one at this stage. The only time we'll need to create an account for this course is if you want to push an image up to a repository hosted on Docker Hub. If you don't want to do that, then you don't need to go ahead and create an account. But what we want to do is we want to figure out an image that we're going to use for our fast API, a Docker container. And so just go ahead and search for Python. And what we're going to do is we're going to use the official Python image. So select the official Python image, and you'll see that there's a couple of different options. So you can scroll down, you can see the different versions of Python. And we're actually going to use version 3.9.7 in this case. But you can see that with the default Python image, we have all of the different versions that we could pretty much ever want. And then they got Slim images, they got the Alpine images as well. But we're going to use just the standard image. Now, if we use this specific image, the problem with this is that this is just a basic image with Python. There's nothing else on it. And at that point, if we just have a basic Python container, then we have to do all of the work of copying our source code onto the Docker container. And then we have to install all of our dependencies and set up our application. And that kind of defeats the purpose of Docker, because the main idea behind Docker is that we actually create an image that has everything that we need to run our application. So we just start up the image, or I guess we technically start up the container, which is made from the image, and that should just have everything it needs, and it should just start working right away. So that's exactly what I want to do. And to actually get that to accomplished, we're going to have to create our own custom image. And all custom images need to start off with a base image. So we're going to start off with this base Python image, and we're going to customize it by doing a few things, including copying our source code into it and installing all the dependencies and setting up a few other details. So to actually create a custom Docker image, we're going to go to our project directory, and we're going to create a file that's referred to as a Docker file. Now, this Docker file is going to have all of the steps necessary to create our own custom image. And the first thing that we have to do is we have to set up or specify our base image. So we're going to use this Python 3.9.7 image as the base image. So what we do is we say from, and then the name of the image. So this is the Python image. And then if we want to, we can also do a version. So I'm going to do 3.9.7. And if you're wondering where I'm getting this from, this is all from the documentation. You just say from, the name of the image, which in this case is Python, and then you could see the different tags. So if you want 3.9.7, slim, bullseye, you got that. And if you want to see them going over that in an example, we're kind of basically just following this essentially. The next step is going to be an optional step, but I always like to do this. We're going to use the workdir flag, and this is going to set the working directory. So I'm going to say this is going to be user source /app. Now, how do I know that there's a folder called user/source? I've actually run the Python image myself, and I checked to see where I could actually set up my application. So I found that there is a path here, and then I want to create a folder called app, and this is where I'm going to store all of my application code. And once again, you can take a look at the documentation, and it does the same thing. So if you're ever lost, just take a look at the doc, and it's going to help explain things. But like I said, this is the optional command in this case.